Hey everyone, my name's Sori, and today we are going to soar higher in education. Tune in for today's lesson because you will not want to miss it.
Okay, so today we are going to be talking about trigonometry with right triangles. So yeah, true right triangles. So first things first is we're going to be looking at Pythag and Saka Toa. So your only prerequisites at this point would be knowing how to reduce fractions and also being able to square numbers and isolate variables. So first things first, we're going to look at the Pythagorean Theorem. And so what does the Pythagorean Theorem state or do? A squared plus b squared equals c squared, with a and b both being the smaller sides of the triangle and c being the hypotenuse or the longest side of the triangle. Let's see that in real time. So this would be A, this would be B, and this would be C. Again, C, that's your hypotenuse. That's the longest side. So we use it to find, the value of the length of the sides for the right triangle. Okay, so let's see the Pythagorean theorem in action, or what I mean by that. So here is a triangle. Make sure I denote this right triangle with the appropriate notation. And let's say I have 2, 3, and I want to know C. So with the Pythagorean theorem, I know a squared plus b squared equals c squared. I'm looking for C, so I bring that down. I know a squared is 2 squared plus I know b, and so b squared is 3 squared. So now I have 4 plus 9 equals c squared. 4 plus 9 is 13, and that's equal to c squared. But I want to know what c is. So to solve for c, I have to take the square root of both sides. And so c equals the square root of 13. Likewise, let's say you already have the hypotenuse. And you want to solve for a side. Let's say this is 9. And this is 6. And I'm looking for this. So I know my C value, or my hypotenuse, is 9. I know the length of my base is 6. And I'm looking for A. So, same equation, Pythagorean theorem, A squared plus B squared equals C squared. I don't know my A, that's what I'm solving for, so I just bring that down. Plus 6 squared equals 9 squared. A squared plus 36 is equal to 81. A squared equals 81 minus 36, because remember how you isolate the variable is doing the opposite on both sides of the equal sign. A squared is going to be equal to 45. To solve for A, I must take the square root. Note that I'm going to look for any perfect square values in the square root. I know that factors of 45 are 9 and 5. 9 times 5 is 45. I can take this perfect square out. So I have A squared is equal to 3 root 5. I'm sorry, A is equal to 3 root 5. Let's look at something else. Let's say I have 9. I have 2x, and I have x. So the only value I know is the hypotenuse. And my base is 2x. And the side, or the height, is A, is x. So now using the Pythagorean theorem, I have A squared plus B squared equals C squared. My A is x, so I have x squared, plus my B is 2x, I have 2x squared equals C squared. X squared plus 2 squared is 4. X squared is x squared equals C squared. I'm sorry. Equals 9. I apologize on that too. 3 squared. So I have x squared plus 4x squared equals 9. And then have 5x squared is equal to 9. I divide each side. X squared is equal to 9. over 5. The square root of x squared is equal to the square root of 9 over 5. Again, I have a perfect square at the top. So I have x is equal to 3 over root 5. A equals 3 root 5. B equals 6 over root 5. And depending on your professor, you may or may not have to rationalize the denominator. So I would ask. Okay. So let's do some problems with the Pythagorean theorem. So I have this right triangle. And I have x. And I have x. And I'm going to say is equal to 15 root 2 a squared plus b squared equals c squared. X squared plus x squared equals 15 root 2 squared. Remember, when you square any square root value, it's just itself outside. So it's 15 times 15 times root 2 times root 2. Okay. You have 2x squared on that side. Okay. So once you do that, 15 times 15 is 225 times the square root of 2 times the square root of 2 is just 2. And that's equal to 2x squared. Remember, you can divide each side by 2. I'm doing that before I actually multiply in because I see a 2 on each side, so I can just take it out. So now I actually have x squared is equal to 225. I know that's a perfect square based on hearing my own personal knowledge. X is equal to 15. Please note that technically the square root of x squared is actually plus or minus x, but because it's a length, the negative x value is an erroneous solution. You don't need it. You're only looking at the positive because you can't have a negative length. That might have been someone's question, so wanted to answer that. Okay. Let's look at one where we're looking for C. And I have 7 here. And I have 4 here. and a 4 squared plus 7 squared equals c squared. 16 plus 49 equals c squared. Plus 9, 15, so you have 65 is equal to c squared. You're going to take the square root of 65 and the square root of c squared. Are there any perfect squares in 65? I know the factors are 13 times 5. These are both prime numbers, so I can't break that down further. So c is simply just equal to root 65, which makes sense because 8 squared is equal to 64, and this is greater than 8. 8 is greater than both these lengths, so that makes sense that that would be the hypotenuse, because remember the definition of hypotenuse is the longest side on the triangle, specifically the right triangle when we're talking about this theorem. Let's look at some special case triangles. We have 30, 60, 90 triangle, and we have, and we're just, these are not drawn to scale, 45, 45. Remember, this would be called what's an isosceles triangle. Honestly, this is scaling, I guess. So why do these triangles matter? These are special case triangles, ones that you'll have to be able to identify, especially when it comes to trig. And so what's the specialty of the 30, 60, 90 triangle? For a 30, 60, 90 triangle, that hypotenuse will be 2a. The height will be a. And the base will always be a root 3. Meaning if you have a 30, 60, 90 triangle and they tell you a equals 2, you know that the height is going to be equal to 2. The base is going to be equal to 2 root 3. And the hypotenuse is going to be equal to 4. This is just by definition. Every time. For a 45, 45, 90, you know that both sides are going to be the same because it's isosceles. And then the hypotenuse is always going to be so we actually saw this on the last example where we had the x 15 root 2. 15 was our x value. So both sides ended up being 15. We saw that in action on one of the last problems. So if you are ever asked to find the sides, you won't actually need to use the Pythagorean Theorem. You can if you want to, it's always going to work, but these have their own special definitions.